Okay, so with regards to this op amp here, which has failed. Now, also, I think I've shown the circuit diagram, or the data sheet. Sorry, pretty sure I've shown you that. So here is the actual pinout of this device here in orientation too. There's a little tab just on the top facing that way, which is just here, which indicates pin 8, not pin 1, which is why I was getting confused by the pinout not making sense. So anyway, so that's pin 1 there, which is pin 1 and pin 8 have got a capacitor across them in this configuration. It's about a balance thing. It's a tunable option. So it's compensation or something. There's a negative and positive of the op amp inputs, or inverting, non-inverting, how you want to say it. There's a negative power supply. There is a pin which isn't used. It's a balance pin. There's the output from the op amp, and there's the positive power supply. So that's a configuration I have to deal to. Now what I've got to do is I've got to substitute with one of these parts, because that's what I've got, and I can't seem to find a CA301 or a LM301 particularly easily. I mean, you probably can get them, but I've had a quick look at my usual sources and none of them had them. Only a couple of them, so I could probably look more detail and actually find one, but for now I'm just going to make a circuit and prove my theory first. You know, in case this part isn't actually stuffed, I might be completely wrong. But so I'm going to build this with the MC4558, which is actually a dual op amp, so I'm only going to use half of it. And it's got slightly better specs than this device. Actually, it's got a slightly higher voltage rating on it, which I think this one's actually underrated for. So you know, I'm a bit suspicious about that part. Anyway, so that's the pin out of this device. So I've used the same designation. So plus power supply, negative power supply output, inverting, non-inverting inputs. So I'm going to put this on a little bit of perf board, and I'll put some wires on there. I might use some long jumper pins. I'll see how the physical fit goes in there. I mean, it's only talking about those pins there and those 3 pins there, so it's fairly close together. I might be able to put hard wires straight into the board rather than having like a little flying PCB. So that's the plan. I'll do that, and then once I've built that up and installed it, I can retry it and see if it fixes the problem. Hopefully it does. We'll see. Yeah, that's the next step. Alright, so now I'm going to, I've made a little bit of a board up. I haven't finished it obviously, I've only just soldered that in. I've got to desolder that device. You can see the mess I've got on the back here. This is the jumper I've got there to provide that 15 volt rail, because it's linked on the other side of the board. On the main back plane. So this is what that link there is for. These are the negative supply, that's the positive supply, that's the 0 volt reference, or 0 volt rail, and that's the error control signal going into the op amp. So that's why it's a bit of a mess. It's all this tapping in to try and figure things out. There's the device which I temporarily replaced, that regulator, 15 volt regulator. Actually I think it's arrived. I think the new part's arrived. I might have to record a bit of video for mailbag for that. I think it's turned up, in which case I can replace that part properly and put the right part in. So this mess, but anyway, it's all part about trying to figure out what's going on. So I'm going to desolder this part and get that out, and I shall work on tacking in the temporary replacement. It might be a permanent replacement, who knows, but we'll see how we go. Okay, is that it? Looks like it's still fairly well attached in places. Only tweezers. Let's have a look. So about the lighting, I've had to disconnect some of my lights because I'm using the power supply for this testing, because I use my lab supply for some of that stuff. Yeah, a lot of these pins are still soldered on the other side. Yeah, okay. Do some more. Just try not to put too much heat into the board, that's all. It's going to be a tricky one, sticking to the top half. I'll come back when I've done it. Actually, I'll show you what I'm doing here. So I've got the legs here, I'm going to break them all off from this side. They're just touching on one edge. I've just got to try and get them all broken off a little bit. Then it should just fall out, hopefully. They're all moving just fine, just touching. There we go. Right, so there's the part out. So the next step is to basically make this into one of these. Great fun. Right, so there's the very rough layout. I've got it kind of lined up. Now what I'm going to do is put some heat shrink over the legs just to make sure there's no shorting out, because that could be very bad. Would you go better if I could find where I put my cutters? I know where I put my cutters. I'm going to have to get them. Hold on. Here we go, cutters. So I just stick some shrink on over these. Don't need to be full length or anything, so just has to be something there to make sure it's not going to short out against something else. Should be enough. Now I'm hoping this is going to be a temporary fitment. I don't want these to be permanent. This is pretty ugly setup, so it's not the best setup, certainly. This is not good enough for like a full-time permanent fix, but I'm hoping to get the right part. This will just at least allow me to confirm whether or not this is the problem, at least in theory. Let's have a look at this. Okay. Now, let's try and fit this thing in. Okay, get the correct orientation. That one's slipping back off. It's not grabbed on very well, that one. That's right. It's a little bit fiddly. There we go. Right. So what I can do now is I can tag that in place and try it again and see what actually happens. And if it works this time, then I know it's definitely op amp, which I've got sitting just here. So I'm not 100% sure it's blown, but I think it's like fairly sure. It's not 100%, probably 90% sure it's blown. Anyway, let's tack this in. And then we shall try again. I need to tack that green wire back on again. If that's gone. I won't bother cleaning the flax up yet. I just want to test it. I'll clean up afterwards if it works. Right. Let's make some space before I get a bit knotted up here. I shall be right back. Right, I've got it arranged. I don't think I've got anything. Let's turn the power on, and that's set up to measure. Power on. Ooh, 10 volts. If I adjust the pot, nada. Nothing's changing. Ah, dummy. I need to put the chip in. Let's put the chip in. Where did I put the chip? I We'll be right back. Okay, now I've got a chip. Alright, so I can get this focus on it. Here you go. MC4558CN, that's what I'm using. Power is currently off. So let's plug the chip in. Turn the power on. Right, now let's try adjusting the pot. Hey, we have life. It's doing something. So that is working now. No, it's supposed to be 15 volts output, so we'll stick it on about 15. There you go, 15.1. I've got a 250k pot, so it's a huge adjustment range. Minus 15, that's fine, and 20. Perfect. Right, so that should now work. It's a bit of a bodge, but yeah, it will do until I get the right part, if I can get the right part. Okay, so I've got them out. Here we go. Let's have a look. LM, the numbers LM723CH. Sure enough, that's what they're marked as, and they look about right. So I'm going to install one of those and take this temporary bodge here, abomination, take that back out. Yeah, I'll come back in a minute. Okay, so got it unpackaged and got the lead spacings, yeah, roughly. They're not going to be right. So it's desoldered apart. So there it is there. That one there's got to come out. And it's out. I'm glad I bought the desoldering gun, I'll tell you. Now, so I've got to try and get this thing orientated correctly. There's the little tab that goes on there, which lines up the dot on the board. And now I've got to get these legs to all line up and pop into the right places. That's always going to be fun. We've got so many. We shall see how lucky I am with this. Oh, it's been pretty easy so far. Down there. That's not right there. That one's got to go in. On there we go. She's in. And it's in the wrong place. It was around by one. Right, let's tip it back out again. There we go. Try again. Because the legs are slightly twisted sideways. Right, that's why you always double check. Try again. There we go. Now they're in. Right. Sit it down quite nicely. Fold some of these out a bit so I can't get it to fall back out. Right, and we'll solder that in. And hopefully that will resolve that issue on that power supply section. Which was it 15 volt, wasn't it? Yeah, 15 volt supply. So, yeah. Let's get this soldered in. With legs in a way. Alright, let's see what it look like. Yep, all good. Nice little solder points on that side. So yeah, so apart from my little bodge here with this op amp now, it's okay. So yeah, hopefully I can get the right pop out part for that and actually replace it with the right part. I don't like to do bodges like that. As you can see, I'll replace this with the proper part. So anyway, let's snip all these off and I'll have to come back to it. Clean. I'll give all these other bits a clean. Actually, I'll do this one as well. This is This is going to be in there for a little while, I think, until I can get that right part. It could be weeks. Or maybe even months, or possibly years if I can't get the right part. Anyway, give it a clean up. It's better off soldered. Sticking my fingers. Right. I've been asked a few times about where I got these from. These are just makeup removers, lint-free makeup remover pads. They're for doing nail polish. Not for me, obviously. But, I was looking for lint-free pads on AliExpress, and these have popped up. So I thought, oh yeah, that looks like a good idea. So I bought some because you know, a few dollars. They weren't that expensive, and yeah, they work really well because they don't shred. So they do shred a little bit, but nowhere near like normal stuff. Because I'm scrubbing it with a toothbrush at the same time. But you know, normally you wouldn't get that much. It's going to prove me wrong now, but yeah, usually pretty good. So now I'll clear all these bits off, and then I'll reinstall it in the main unit, and we'll do some more testing. Right, so I've got the card back in. Power is plugged in. I just need to turn it on, and then we'll see what happens, if it goes bang and fizzle and pop, or whether it's actually going to work. What I need to do actually is get my test leads out, which are underneath it. Hold on. I'll better do some voltage measurements while I'm at it. Maybe, because I've got to set this reference here. Now I've done that. Now I've reinstalled that part. I need to reset that voltage level. I don't know where it actually is right now. So everything I need to do is figure out where I want to test it. Okay, right, I can see. That's right. Okay, turn this on. Okay, well, the smoke coming out is probably not a good sign. Where's that from? Damn it. What's going wrong now? Where did that come from? What just smoked? Something did. But what? It might be there. Can't smell. Can't smell where it is. I don't know why it's done that. Oh dear. I thought I was ready with that one. Alright, so here's the board back out. Now the only thing I can see that's burnt is this resistor right here, which is R33. Now according to the service manual, R33 is the series resistor here. So that's the part I just replaced as well. That's that voltage regulator, current pass transistor, and that resistor there is burnt. So I saw smoke, and that's the only thing I can see. It's looking burnt. I checked the current pass transistor. That seems fine. It doesn't seem to be faulted. So obviously it's been an excessive current draw, which is interesting. Question is why it wasn't doing that before with the other regulator in there. So I'm wondering if this part here is actually dodgy because it's across that resistor. Maybe it's not from this circuit, but it's from here. So I'm probably going to have to try and power the circuit up. Yeah, just power it up outside again, which is a bit trickier in that particular circuit, but I could do it before. And just test without anything else being plugged into it and see if it fails again. But yeah, it's a bit disappointing. I thought it was going to be ready to go then, but no, well, the sticker's still right. Right, so I've got my test jig set up here. This is all hooked up, so I've got a dual rail supply going to it, current limited, and let's see what happens. I haven't powered up yet. That's drawing a lot of current on one of the rails. And now it's stopped drawing current. And now it's drawing current again. That's interesting. And that was just a thinkable. Something pulled current. The thing is, I'm not quite sure whether it's this part here or this or that tantalum, right? They're across that supply. The only things that are across that supply is that regulator and that tantalum. However, the regulator is the only thing that's across that resistor. So the current draws fine again now. It's dropped back down. It's like 12 milliamps. Let's do a voltage measurement and see what we get. But I suspect that it's stuffed. I really do. Let's get pros right around at least. Stick one there and 2p8, 22 volts. I think it's dead. I think this one's dead again. Now, is there an issue external to that, which is what's causing the thing to go? That's the question. Measure was blown. Should try voltage adjustment, just in case it's working. No, that's dead. Yeah, it's not good. Dear. So pin. That's the voltage in. 25 volts in. And was it right? 10. Trying to see one. 1, 2, 3, 4, 5, 6. That's the output there. Output saying 23 volts. So it's a bit tricky to do. So I'll see if I can just see the output changes with that. No, nothing. So it looks like that regulator is also gone. Now, as I got these from AliExpress, you have to wonder if these are fake parts, right? It's entirely possible they're fake parts. It could just be as a poor quality part and that one's failed. I could just try placing it and see if it goes again. I've got 5, so, well, 4 now. Yeah, I'm not happy that there's a potential there for this to be bad. At least if it's just localized to this, it hasn't done any damage to the actual unit. It's yeah, it's not good though. I'm wondering if I should just try and knock together something else. I mean, I had that 15 volt regulator in there that's working okay, but I think this has to be a fairly precision supply. I think it has to be fairly accurate, and I think it's also needs to be compensation. Needs to compensate for voltage drops as well, so that's why it's got that closed loop system in it. So as it gets loading on it, it compensates for the voltage, whereas the other regulator won't do that. I can probably replace it with a LM317 and do the same kind of thing. I might have to look into that, because I mean, I'm not confident about these parts. I think they're probably fakes, and that's the risk you pay. Right, so I'm going to desolder this again, replace it again, and we'll try it again. Fun. Right, that's the part installed again. Well, the new part installed. Let's just set this current a little bit lagging. Now I've got that going. Right, turn the output on. Nothing bad has happened this time. This time it's looking okay. Maybe that's a dodgy part. Okay, there's no current overload right now, so it's just try and measure it, and I might flip it over and measure it. Actually, might be a bit easier. So I need to measure from, I'm losing myself now, there and there, right, there and here. It's doing 14.6 volts, which is close. So, we'll try this again. Maybe I just got a bit unlucky with that first part. There we go. That's adjusting to 15 volts. That's fine. It's going from 13.8 through to 16.9 volts. It's on the Vici, so there's a bit of error there, but close enough would be good enough for this point in time. Let's go for exactly 15 volts. Here we go. Right. Well, maybe I just got unlucky with that first part. Maybe. Anyway, I shall try again. Right, let's try this again. Fingers crossed. Right, power's plugged in. Let's switch it on and see if there's any smoke. Let's check the resistor. Yeah, not hot. That's okay. No other signs of smoke, so that was a bit of a weird situation. It seems to be behaving now, but I don't think there's going to be anything else really with this thing. Still got an overload indicator on it. I really need to do something about this fan and the housing and stuff. It makes a heavy racket. Right. Let's see if there's any voltage output now, just in case anything's changed and I've got those other power supplies working. Stick that in there, stick that in there, stick it on AC. Turn it on. Yeah. Nothing there. Still no output, so it's still got more problems yet. Still got more problems, but the power supply section should be okay now. I suppose I could do some extra voltage measurements there just to verify that right now. Repower it and just make sure it actually measures okay. I expect they will. They're actually really hard to get to. Right down in there. Let's have a look and see what I can do. Just verify the ones I can get to at least. Just do that. Spin around a little so we get to it. So like that. Minus 23. Plus 23. I'm not sure those are right actually. Pretty sure it's plus 15. Something else gone wrong? Am I using the wrong reference point? Well, we got that test point over here and the ground track there. Exactly 15 volts still, that's fine. So, I'm suspicious about those other ones again now. I might need to double check those. There might be another problem again. Okay, interestingly, R45 is listed as C45 over here, but it says resistor, wire round, 86.75. I think that's supposed to be K. 0.1%, 5 ppm, 0.5 watt card, which matches the description, right? So I think that's K. I hope that's K. It might not be K, it might be ohms. So I still need to find 46. Just want to verify that 46 and 49 are both missing off this list. So I'm just trying to see if I can see them anywhere else, but there's an R69. No, I don't know. Anyway, I'll figure it out. Okay, so I removed that resistor, and yep, sure enough, it's definitely burnt out. No doubt about it. And the closest thing I've got is an 82 ohm, 82k. I don't know. This is not a good replacement. This is really bad replacement. This is all precision, you know, 0.1%, that sort of stuff. It's really high precision resistors, and I've got this bog standard part here. Yeah, this is probably, you know, a really bad thing. So, but I've got no choice. Just in order to determine if I can even get the thing working, I need this, and that's just the way it is. I'm afraid I need to put this part in to see if it will even work, because it may not even work. So let's just shorten his legs a bit, make it easy to get it in there. I'm going to have it standing off the board as well, just to make sure it doesn't get too hot and that sort of stuff. But yeah, it's not a good look. It really isn't. It's not what I want to do, but I'm afraid there's not much I can do about it. It is what it is. Trying to get this into the hole here. So I stand it off the board like that. Try and push that in a little bit, wedge it in. You'll solder that in place and try it and see if it corrects that power supply issue. But yeah, I think this is part of that thing I was saying about cascading failures. You know, it's one thing goes and it takes out a few other things because there's no protection circuitry. If there had been a fuse on that power supply, and all its outputs on the power supply outputs, if they'd all been fused, that wouldn't have been damaged. You know, it's just one of these things. It's disappointing, to say the least. You know, I don't see me getting one of these. You know, it's going to be impossible to find one. I might be able to find some other kind of precision resistor, but it won't be the same value. I don't know what I'm going to do with that. That's a tricky situation. I'm not happy about it. But anyway, give us a clean up, and I'll put it back together and go from there. Right, so I've got it reassembled, and let's get this thing ready to measure voltages and make sure my probe stuff here. And I shall turn it on and see if we get any bangs or smoke this time. Yeah, it's great fun, isn't it? Right. Let's try and measure these voltages. Still getting high voltage. So it's not right. If that was working, I should be getting a correct voltage now. Oh, I'm going to have to think about this. Alright, so I've hooked up some wires onto the power supply to check the inputs on that op amp. So I've got the Fluke and the VG on each one. Let's see what we get. Interesting, the VG is not getting much at all. Maybe it's not pushed in fully. Alright. I'm going to get 2.9 volts on that one. Let's wait for this time out. I'll try turning it on, see if anything happens. No. I might have got something wrong. That's definitely the 0 volt reference. That's definitely on that reference. I don't know what I've done wrong now. Disaster. Alright, so now I'm just going to try measuring just on the across the inputs of the op amp to see what I get there instead. Because the op amp's based on the output's based on the difference voltage anyway, so that should probably tell me what I should be doing anyway. 2.9 volts. Doesn't seem quite right, does it? Yeah, what's going on here? What's going on? I'm confused myself now. So I thought I'd just better check Q7 to see if it's okay in case it's blown. That one looks okay that way. Yep, that looks cool. Okay, Q7 looks alright, thankfully. So let's just measure these resistors here in case there's an issue there. I mean, it is, well, it looks like blistering, but I don't know if it's actually an issue or not. Yeah, we'll see if it looks okay, and I'll try and check the values. So this one here, which is 46, I'm measuring 0.84K, so 844 ohms or so. Yeah, got 0.2 ohms resistance on the probes. So yeah, about 844 ohms I'm getting on that one, and this other one here is 972 ohms. Let's just find out where they are in the manual. There's a page with the whole listing. Actually, I've got, oh no, so I haven't got that section printed out. Where is it? Let's see, IEEE. I might have to come back once I find it. Actually, it's A8. Hold on, I'm getting close. A12. Here we go. So R40. Where is it? It's grouped together. R44. Where's 46, 45? I don't see them. That's interesting. Oh dear. I think I just found a problem. Now you've got these precision resistors which are around these custom things here. And if I look on the back of this one, it's all on it. Can you see that? It's got hot right there, and it's stuffed. The windings are burnt out. Right there, there's all the windings floating around. That resistor's knackered. That might be what's wrong with it. So yeah, that's not good. Dear. Oh dear. Let's figure out what that is and how it could have been damaged. So that resistor is that the right board? It's over here, and it is R45. Yeah, R45. R45 is where? Oh, is it that one? Can't read it properly. It's 46, 48, 47. It might be one of them. I'm going to have to try and find a better section of a manual for that maybe. So it's going to Q7 and R46. R46 is next to it. Let's just try and follow the circuit instead. See if I can confirm that or not. Nothing on that side. And trying to follow it here, it goes to there, yeah, it goes to that one next to it, and Q7, yeah, that's that one there. That is R45. Problem is, I don't know what value it's supposed to be. I can't read it. That is R45. Just going to mark it on the drawing. Yeah, okay. Well, let's look in the manual some more and see if we can find out what it's supposed to be. But I'm pretty sure that is completely knackered. And so it's going between Q7 and the other circuitry. So I need to figure out why. That's on the output. Ah, that's between Q7 and the output. So that would have blown when the op amp blew. Yeah, so when the op amp failed, it burnt out that resistor. That's because it'll be going through that path there. Yeah, so that's what's happened there. I need to find out what that value is and substitute something and see if I can make it work. But yeah, that's pretty stuffed. The one next to it's got blistering, but yeah, I have to just measure those to see if I can make sense of what those values are. See if they look okay or not. Right, so the bit board now I've just pulled out as a reference supply or reference assembly. It's in here somewhere. It's all shielded in there really well. Now I'm suspicious about this particular assembly because the error control signal comes from this board to the power supply, and the power supply output voltage was wrong in that section, which I just repaired in the for the op amp control section, and that makes you think, okay, well, I know that I tested it in circuit by injecting my own signals and that it seemed to behave correctly. So it appears that the signal from here may be wrong. So I need to pull this apart, inject my own signals into that section and test that particular section of this board. And just test any components I can find as well, see if there's anything there which looks a bit dodgy. But yeah, this unit's been quite a pain. It's taken me a lot longer than I thought it would. Yeah, I have to say I'm not a fan of this particular unit as far as working on it goes. I mean, it's easy enough to get apart and things like that, but it's just the cascading effects of failures that happen. You know, you're cascading failures, and that's the bit I'm not liking. One part goes, and it seems that something else goes as well, and it's just like the actual outputs in the power supplies, for example. There's no fuses in there. You know, if it had been me, I would have put fuses in those lines to see if one of these cards goes, it doesn't take out the whole system. But yeah, at least you know you've got a fault with one of these cards rather than just a power supply fault. Things like that. Right, well, let's see what we got. Right. Based on how tight those screws were, I'm not sure anyone's ever been in here, but I don't know. I could be wrong. So in here somewhere is the reference. There's a trimmer there as well, which would be the 0 reference point. There's a few tantalums around, so I should probably check all those, make sure they're okay. A whole bunch of logic. So this reference board is actually in like 2 sections. So let's pop the back off. Let's have a look at the back. In case there's anything on here, so burnt out tracks, etc. Well, it looks okay. It's like there's been some soldering done just there. But from what I can see, it looks alright. That may or may not be factory, but it looks a little bit fresh. There's nothing obvious there anyway, so it's looking fairly good. Maybe this hasn't been touched. There's a capacitor there as well, I can see that soldering, so it's probably nothing actually. Right, let's do some checks and see what's going on here. Let's just do some basic short circuit checks on the tantalums first. and we'll go from there. It's okay. It's okay. That's right. That's right. There's capacitors. That's right. Cool. That's all of them. So those all seem fine. Now in here somewhere is a reference. 15-volt reference or something. Let's have a look in here. Get back to the reference supply section. So now the area control signal is EC high, that one there. That's when it goes to the power supply. So this section here, which is Q7, which is an amplifier by the looks of it. There's a bit of reference there. There you go, reference amp here, U30. And yeah, it looks like it's just current limiting supply, op amp. Goes to Q7, so yeah. So I need to test this circuitry here. So what I needed to do is inject a 15-volt supply into it. There's a minus 15 volt there as well, and a 0 volt reference, I think. Yeah. So 0 volt reference. Just want to see what else I might need. This bit of the circuit here that's just grounding, style grounding, so that's okay. That's something. That's a different aspect that I'm not looking at right now. I'm just looking at this reference circuitry. So I also want to make sure that this 15-volt reference here is actually working. So yeah, I'm going to insert, hook up to my power supply, and see if this is generating a voltage. Do I need to even use this bit here? I've got plus 20 volts there as well. Okay. If I'm not using that part, I don't need to worry about this ground trace. I think I need a 15 volt and a 20 volt supply. 15 volt to power it and 20 volt for this section just here. I think that's all I need. Because I'm not using this, I'm not using any of this. These are isolated sections. So this is the only bit I'm testing right now is this piece here. So I can do that quite easy. Okay, so conveniently that service manual for the Fluke 5200A arrived on CD, which I ordered off eBay, and it's supposed to be a high quality version scanned straight from manual, and indeed it is. It is a really nice quality version. So I'm actually really glad I paid that money and got this, even though I already had a copy of a manual. So here is the section which I'm having issues with. Now on the manual I had, I couldn't actually read these values and stuff like that. On this one I can read it. So it's an 86.75, no K here. Alright. Now the interesting thing with this is that anything which is measured as K does say it's a K. So what I think is that's 86.75 ohms, not K. Now these have got notes here as well saying R48, R49 are part of a lot. Part of it. It's got note here, note number 2. And if I bring the page over here, note number 2 is part of a match stamp set. Right, so you have to replace that set. So thankfully the ones which are damaged are not part of the precision set, but it's still a precision resistor, so it may have an influence. What that actually is I don't know, but this is probably why the power supply still doesn't work correctly, because I put an 86K in, not an 86 ohm So, well, I put 82k in because that's what I had. So I need to change this resistor again, and that might resolve that power supply problem issue, because there's not enough correction voltage getting through. And yeah, so I think I should go from there. And I've also got the riser card arrived, so I'm actually going to think about plugging this whole assembly in, this whole card in the riser, and do measurements as it's running. Yeah, so I thought I'd just cover that. Right, so I've just pulled this all apart again. This is the same unit, and what I've had to do is try and match that resistor. So I've used a 240 ohm and a couple of 270 ohms in parallel, and that gives me 86.25 ohms. So I'm half an ohm out. I'm thinking that's probably close enough, at least for the purpose of getting the thing to work. So yeah, that's what I've had to do there. Trying to find a precision resistor with the good tolerances and stuff like that, it's going to be really hard. I'm gonna try and find one, but it's unlikely that I'm going to be able to find one of these. You know, there's the part number on there. If anyone has one which is scrap, that's great. You know, get in touch. I'll be happily pay for one. Right. So it's at 33953 something, 531 is it? Just like 339 531 0689. Okay. Yeah, but if anyone's got one of these units which is scrap or partially blown up, I'll certainly be interested in parts. You know, yeah, it's going to be an ongoing project, I think. Anyway, so that's that bit done. It's close to the original value now. It's not perfect, but it's close, so I'm happy with that for now, and I'll at least be able to carry on with testing from that point. Right, just about ready to try it out again. Now I've put it back together, obviously, and we shall see what happens. I've got the Fluke measuring. Oh, that's not right. I need it on volts. Fluke measuring volts of the input to the op amp on that power supply card, and I'll be probing the actual voltage output on the test points with the Vici. So we shall see what happens. Make sure nothing's shorting out, but those wires hanging down should be good. Right. Come on. Voltage is still wrong. I'm seeing 7 volts. So I don't know what's going on there. Still seeing 22 volts on that card. Shouldn't be seeing 23 volts. I'm seeing 7 volts on the Fluke across the input to the op amp. So it's not what I'd expect. Is it the 0 point adjustment? I mean, I've had to change that part. Maybe I should just look at that. Let's try that, shall we? That's not changing anything. Reference adjust. Also not changing anything. So I don't know what's going on there. Waiting for it to go to standby so I can turn it on, see if anything changes. Okay, that's on. Nothing changed with the input of the op amp. Still showing overload the whole time. Let's see if there's any output. I don't think there will be somehow. AC volts is on there yet, so still no output, so still no progress. Right, I guess I'll carry on.